welcome to another Spastic Kangaroo tutorial. Today I'm going to be teaching you more about Lua. So let's get started. I've decided to add a little presentation at the beginning of videos now, thanks to someone suggesting in the comments. So we have a quick overview of what will be taught, which will help with the structure a little bit. So in this tutorial, we're going to be looking at functions, just a new concept, and we'll be cleaning up our code a little bit, as well as learning a little bit more about tables. So I've just got some Lua code here of a function. So a function is a block of reusable code. So here I have the code print hello, and it concatenates with a variable called name, and then with an exclamation point. So it prints out hello, whatever your name is. So we have the syntax here for our function to create a function. So it's function, you have your function name, and then you have whatever arguments you want to pass to it. So you can create you could create arguments however you want. You can also create functions without any arguments. So you could just have an empty hi function, which would just print hi if you wanted. But you do have the option to pass arguments. So I have 3 examples of this, and if I would run this code, it would say hello Chuck, hello Bob, hello Jeff, and that way we don't have to rewrite this code multiple times over and over and over again, with each name being something like this. And well, there is a little bit more code here than if we just put these 3 lines here. Functions become extremely useful when you have a lot more code to copy around, which we do in some cases, such as our game. So we're going to have a function for each room and a function to get our inventory and stuff like that. So this will help us have a little bit less code than we currently have. And you always want to cut down on code if you can. You always want to remove repetition and make it easy to modify the code. It'll also make things a little bit more flexible. Currently, we could even make things even more flexible than they currently are, which will be extremely useful later on. So let's go do that. Let's just edit our main file again. Alright, so this is where we left it last time. I've added a few extra comments in here. We're on part 4 now. Yay. Okay. So we have a lot of repeating code right now, because each time we have a room, we have a while loop, and we have input, we have an inspect function every time, stuff like that. So let's clean this up a little bit. We're going to just create a function for viewing our inventory, because we have this all over the place, and these 3 lines of code all over the place, and it's kind of messy. And this is a fairly simple one because we don't take any input. We wouldn't have to pass it any arguments. So let's create a function, and we will call it getInv. Right, and then you're just going to create 2 parentheses here, because we're not going to pass it any arguments. We're not going to pass it any variables to grab and use later in the function. And then you're just going to type n like any other function, like any other block in Lua. So let's just copy our code. We don't even need to rewrite it. So we'll just copy this from here and move it to here. Yeah, that'll work. So we can just get the inventory now. So wherever we actually get the inventory, we can just put the code getInv. So we have our custom function now. Every time we run getInventory, it'll run through and run. It'll go through and run the code inside of the function, and it will print it out. And since inventory, the inv variable is global, as in it's outside of each block. It's at the very beginning of the file, outside of anything else. We don't have to pass it around. That's something else you have to think about once you get into using functions a lot. There's this thing called scope, which we will learn about probably next time, because it's kind of a fairly complex issue. Let's just paste this in everywhere we have our inventory. And that was it, I think. So now, when we run our code, we can run inv, and we can see our inventory. And the cool thing about this, is we can actually add something to, let's say we want to say the number of that, the index of that value. We'll concatenate it with a space, and concatenate it with the value. So now we'll have the index in front of it, and because we have it, we have our function in one place, this code will be updated. This code will be updated everywhere. So now every time we run inventory, no matter what room we're in, it'll update. So inv, here's our code, and if we go, what are my options? I forget what my options are. Exit, that's right. So inv, and then we can exit, and then when we say inv in this place, which is at the path, we have our inventory and we have the index next to it because we have it, our get inventory centralized in one place. Alright, so once you see this, you can see that there are large areas that can be modularized. So let's see, where else? We could, okay, let's see, this code repeats a lot. We could have an error function. So we'll have a function called invalid, invalid command. So invcom. Make your function names kind of short because it'll make your life a lot easier when you have to write them a lot. So don't make them long. Making them long is just a waste of typing, especially if it's a simple function that's kind of self-explanatory. I mean, this is kind of self-explanatory. You can even put a function if it really bugs you. You can say invalid command. So let's just paste this in here. Every time we have an error, our last spot is here. All right, cool. Let's see, what else can we modularize? Well, these entire loops we can modularize, but I'm going to wait a minute to get to that. Oh, how about get input? This is another thing functions can do. They can return the output. They can have an output, so you can assign the returned value of a function to a variable. What I mean by that is we're going to create a function called get input. We're not going to pass it anything, but we're going to return something from it. So we're going to just copy this code in, and what we're going to do is we're going to return the input, right? So what this is going to do is we're going to run, whenever we run this get input command, it'll say, what do you want to do? It'll take whatever the user types in, put it in the value input, and then our function will, and they use this return keyword, it will return whatever we typed in. So if we don't do anything with this, it'll just get lost. So that would be kind of useless. So what we're going to do is we're going to say input equals get input. And what this will do is it will take the value that we return and stick it in the variable input. So this input and this input is not the same. That's actually a scope thing. So we're going to just this input is actually different than this input, and that's kind of confusing. And I'm not going to completely explain it right now, so I'm just going to change this one to I so it makes sense, even though it doesn't matter. Yeah, that's scope. We'll cover that next time. But for now, just make it simpler and name it I, and you'll be able to differentiate between the two. All right. So our input, we're going to do this here. We're going to do this here. We're going to do it here. And good. That's good. So our code is a little bit simpler now. We're gonna write a function to insert into the inventory table, just because it'll be a little bit simpler that way. Then we don't have to remember the table.insert function and then pass the table name and everything every time. So we'll create a function called push inv, and in programming you can push and pop to arrays. That's the terminology commonly used. You push, so that means you add a value to an array, or you pop, which means you remove a value from an array. Or in Lua, it's called a table. So we're just going to push to inventory or pop from inventory. So this will clean up the code a tad bit. So our argument is going to be item, right? So when we push to the inventory, we're going to want to pass it an item. And once we reach, we'll just copy our code to push an item to the inventory. So where is it? Let's see. Table.insert. This bit. So even though it's only one line of code, having a function name here helps to kind of explain it. We're pushing to the inventory, so now we know why we're doing this. So we're going to push to inventory, and instead of a specific item here, we're just going to put the general item. So now when we call the push inventory function, we can add an item in the arguments, and it will add it to our table, our inventory table. So let's go back to where we were before. We obtain magic, and then we're going to push inv, and this inv here is going to be magic, right? So what this does is, sorry, ignore that. What this does is it takes whatever value we pass, which happens to be the string magic, and then it adds it to our inventory. So this allows us to give each function a custom thing to do, and it allows us to do custom things with different functions. And one thing to note that's very important is when you create a function and it has an argument, you have to specify an argument if you run this function. If you don't, you'll get a syntax error. If you do, just make sure you followed the correct syntax for that function. All right. So, is there any other place where we add to the inventory table? Let's see, inventory, and I think that's the only spot. We also remove from the inventory, which we could also add a function to do that. So, I'm just going to organize this by adding the push inventory around the same area as our other inventory functions. Command. Actually, I'm going to name this something different because it started with inv, which meant was for invalid, but it doesn't work in this case. So inv com. I'm going to rename this air command. Same there and same there. Cool. All right. So anyway, back to this. We're going to create a remove pop from inventory as well. Once again, we'll have to pass it something. And we're going to just copy our remove from inventory functionality that we have. Where did we put that? Table.remove. That was it. And we're going to pop inventory a specific item. And in this case, we're removing an index from, we're removing by the index. We can't remove by the value of the string. So what we're going to do is we're going to look through that table. So we're going to say for, we don't care about the first one, so we're just going to use an underscore for that variable name, which doesn't, so we can know that it doesn't matter, comma v in pairs of inventory. So for every pair in the inventory, for pair they mean index value. So we're ignoring the index, which is why I just put an underscore there. And that's just signifying that I don't care about it. We're going to say, actually, no, I do need the inventory, the index of it. Never mind. So we're going to say if the value equals the item, right, which is the argument we're passing, then we can remove that. All right. So remove from the inventory at index I. So what this does is it loops through an array. So let's say we have A, B, C. This is just a demonstration. Don't bother to write this down. And we have our index 2, 3. And what will happen is it'll go through each one. Say, and if I say pop inventory, and I say I want to remove B from my inventory, it'll say, okay, A, it'll go to the first one. It'll say, A, does A equal B? And if it does, then it'll delete it. But it doesn't, so it'll move on to the next one. It says, does 2 equal B? And does B equal our item? And it does. So what it'll do is it'll say, okay, that's the one I need, just delete it. And then it will be left with A and C, and then it'll convert C to index of 2 because that's where it's at now. All right, so that again, because of our ability to create functions, we don't have to put this code every time we want to pop from the inventory. So we're gonna pop in, and we're gonna steal the coin, right? All right. Okay, that's good. So we're going to go on and talk a little bit more about tables. So tables don't have just the ability to be arrays, as in single lists that are accessed by an index. So we can also have what's called a key-value pair. So normally, an array goes A, B, C. So this would be a valid array. Again, don't bother to write this down. This is just a demonstration. You know what? Actually, I'll just create. So we've got A, B, B, and C. And we access, so if we say, let's say x equals this. If we'd say x1, we would get A, right? Because at our index of 1, it returns A. But we can also access this, we can actually set the key that we want. All right, so we can create a key-value pair. And what we do by that is we say, instead of accessing it by an index, we're going to actually set a custom value for this. So we can say y equals, and we're going to create an array here. So we're going to say, let's see, which should our key value? Well, our key is going to be like key, and we can set our value to whatever we want. So we can set our key to anything we want too. So we can have key, and then key, we could have like box equals cardboard. So what you can do with this is imagine it as if it's the dictionary. So you have your dictionary here. So this is our dictionary, right? And then our key is like the word we're trying to look up. So let's say apple. We're looking up the word apple. And our value is like a description for that. So we can say an apple is a red fruit, right? We could have, for B, we could have a box, and it would be a rectangular prism to hold something. I don't know. These are very accurate dictionary descriptions, right? But anyway, we can access our words in the dictionary by asking for them. So we could say dictionary.apple. And this would return, if we say print dictionary.apple, it would return a red fruit, right? And if we say dictionary.box, it would return a rectangular prism to hold something. So there are a few ways to access values in a dictionary table. One way is with the dot syntax, like I just showed you. Another is by using square brackets and then typing the string of the key. So we could say apple, and that would return a red fruit. It's the same thing as this. These two lines are the exact same way of doing there are different ways of doing the exact same thing. It's just different syntax. I personally prefer dot syntax because it's a little bit simpler. If you want to use the string syntax because it looks like array syntax, that's fine. Do whatever you want because it doesn't really matter one way or the other. But anyway, what we're going to do now is we're going to use this knowledge, our new knowledge of tables, and use this to simplify the way we have our rooms. So what we're going to do is we're going to have the room command as a key and the room value as the response. So some of this we'll be able to do right now. Some of it will require a little bit more detailing in the next tutorial, such as this part, because it's a function here. This entire part is a function, and you can assign functions to the value, but we're not going to get into that quite yet. So for now, I'm just going to demo on this input right here. So our function is, let's call it our room function, and we're going to pass it. We're going to pass it a Lua table. So we're going to say t. You can name this argument whatever you want. So I'm just going to name mine t because it's a little bit simpler and it'll make typing it a little bit easier. So let's just copy our skeleton code here. We're going to use this as a reference. So our t is going to be formatted in this way. I'm just going to put a comment here to make sure I have everything straight. So I'm going to have my command, and then I'm going to have my response, right? And we can have command 2 equals response 2, right? So we're going to say while the input does not equal, and we're going to say we could stick this in here. We could put our exit command in here, but I think we'll just pass it separately, so it makes things a little bit simpler. So exit command, and we'll have our t's. Right. We're gonna just have our exit command as something separate. So what we're gonna do is we're gonna say input equals nothing, because we always want to set it to nothing at the beginning. And we're going to say while input does not equal the exit command, we're going to go through the following stuff. So we're always going to want to get the input, so we're just going to leave that there. But this entire set of things here, we're going to leave because except for some global commands, we'll have inventory as a global command, and we also have to leave around our error checking. So if the person doesn't put in the right command, we always want to say that's not a valid command. So yeah. Anyway, let's delete all our crap here, and we're gonna say we'll have an initial bit where we look through all our keys and see if it's a valid command, right? So for k comma v, so key value in pairs. So our pairs command still works. It's just now instead of using an index, it uses a key, and we're gonna just pass it our input. No, we're gonna pass it our table. This is our command table. So for each pair, for each key value pair in our t table, we're gonna go through it. We're gonna say if input, so whatever the user has typed in already, equals, and it's gonna equal our key, then we're gonna print our value, right? And whoops, not do, it's then. So if our input equals our key, we're just gonna print the value. So if our command equals something, it'll just print the response. And if it doesn't, well, actually, okay. One cool thing about and then if it does, we'll just return. So then we don't have to keep looping through. One thing about returns is you don't have to return anything. You can just say return, and what this will do is it'll break out of the function. So the function, it'll quit the rest of the function. It'll skip everything after it and just continue on with execution past that function. Just one of the cool things that functions can do. So you can also break out of it if you don't need to continue on with the execution. So if not, we're gonna check that it is an inventory. So we can delete that and just say if. So if our input equals inventory, then we'll have our global commands after our local t commands. So if it's inventory, we'll just get the inventory. Else, we'll just print the command, the error error message, right? So what this will do is we can now say for inspect, well, let's create our table first. So room commands equals, it's going to be a table, and if the input is inspect, we want the response you are in a cave, there's an exit. Paste that in. I'm actually going to just use double quotes for consistency's sake. And we can delete that bit. If it's exit, we're going to say you leave the cave. You leave the cave. You leave the cave. And everything else is handled. So, wait, did I miss something? No, okay. It's just this is complaining now. So, we don't even need this while loop anymore. We can just completely get rid of that. And we're left with room com, and we'll have our room function. We're going to run our room function. And our first argument is the exit command. So if the user types exit, we want them to quit because we check that in our while loop right here. Our second argument is our T table, and this is our room commands. So we'll pass that in, and once we do that, we should have everything covered. So now this is literally all the code we have for that room. And I'll just delete that, sorry. So now, when I run Lua main.lua, oops, I messed up. Where is it? Oh wait, it's because you're not supposed to put quotes around that. Okay, there we go. So, sorry, in case you missed that, I put quotes around our keys, but we're not supposed to do that. We're just supposed to set that to whatever we want it to say. So let's try again. What do you want to do? We can inspect. We can say our inventory, and we can exit. Exit. Oh wait, didn't catch our exit. So what do we do wrong? Here's why. I got it. We said return, but we don't actually want to return out of the function. We only want to return out of it once we've exited. So we actually we actually don't even need the return statement period. We can put it at the end if you really want to. It's actually not even necessary because it'll just finish this loop and then continue on with the rest of the program. So let's try this again. We'll say inf. We can inspect. Okay. So it says you're in a cave, there is an exit, but then it says you didn't write a valid command. And the reason for that is that we go through the valid commands, and then we always go through this bit here at the end, but we don't want that. The return statement doesn't work, so what we're going to have to do is restructure our code, but that's okay. We can do that. Okay, we're just gonna cheat and create a boolean at the beginning, because that's the easiest way. So we're gonna have a boolean called valid, and we're gonna set it to false initially. So if we print it out, we're gonna say valid was true, valid equals true, in which case else if valid equals false, then okay. So what this will do is it will say we'll go through all our local commands first. If none of them is valid, valid will stay false, and if it's not inventory, it'll go to here, and if valid is false, we're gonna run our error command, right? All right, so I'll go through that one more time, just to make sure you got that. So we have our valid boolean initially set to false. We go through all our local commands that are in T. If any of them happens to be valid, we'll say valid equals true, in which case this else if here will not run. If this stays false because there aren't any local commands, it'll check inventory first. And if inventory is true, it'll skip this else if and continue on. And if inventory isn't true and none of the local commands are valid, we'll just run our error command. So now, when we run this, we say inventory, we can say inspect, and if we say ASDF, it'll say you didn't write a valid command. We can say exit, and we'll leave the cave. So now we're in our new area. If we inspect now, there's a cave behind you, you're on a cliff, etc. So next time, we'll clean this up a little bit more, and I'll teach you how to create functions for specific areas, for specific commands, and that'll make things a little bit simpler. Yeah, other than that, I think we're almost done with this series. There's a few advanced things I might cover to just to see how that all goes. But yeah, we've made good progress. And if there's anything that's been confusing, let me know in the comments, and I'll be sure to clarify it in the next tutorial. So thank you very much for watching. I hope you learned something. Yeah, just let me know in the comments